students, welcome back again. In this video series, we are going to discuss cosine of range series for the function f of x is equal to 2x minus 1 and in the interval 0 to 1. Students, first I am going to write the cosine of range series in generally. Okay. The cosine of range Fourier series in the interval 0 to L. This is with respect to 0 to 1. Okay, is f of x is equal to a naught by 2 plus summation n runs from 1 to infinity an cos n pi x by L. This is in generally, it is for arbitrary period of length L. Okay, this is half of the interval. You people already aware of the interval minus L to L. The total length should be what? Upper limit minus of lower limit minus of minus plus. It will become 2L. So it's a periodic function of a period at 2L. Okay, so it is half of this period. Okay, for this we are writing the cosine of range series. Okay, and the Fourier coefficients a naught equal to, which is 2 by L, integral runs from 0 to L f of x into dx, and the value of an is equal to 2 by L, integral runs from 0 to L f of x into cos of n pi x by L into dx. So now let us take the value of L is equal to, the length is 0 to L, here the length is 0 to 1, therefore L value is 1. Okay. So let us substitute here and observe what will happen. Okay, substitute what? L equal to 1, which is a naught by 2 plus summation n runs from 1 to infinity. This is an cos L value is 1. So it will become n pi x. Okay. So corresponding the value of a naught becomes 2 by 1. Integral runs from 0 to 1 f of x into dx, and correspondingly the value of an is 2 by 1. Integral runs from 0 to 1 f of x into cos of n pi x by 1 or n pi x into dx. Students, first we shall find out the value of a naught and an, then we are going to substitute in this equation. Okay, call it as equation number 1. Okay, fine. Now let us come back here. A naught equal to, which is 2 times of integral runs from 0 to 1. Observe what is the value of f of x. F of x value is 2x minus 1 into dx. So let us integrate this. Okay, keep it to outside. So integration of 2x is just x square, or 2 into integration of x is x square by 2, 2 and 2 get cancelled, minus integration of 1 is x. So between the interval 0 to 1. Okay. Fine. Substitute upper limit. Okay, 2 times of upper limit 1 square is 1. Okay, minus 1 minus lower limit is 0, square is 0, minus 0. So 1 minus 1 is 0. So a naught value is 0. So let me go for an. An equal to 2 times of integral runs from 0 to 1. F of x value is 2x minus 1 into cos n pi x into dx. Okay. So now we are going to use the Bernoulli's rule. Okay, we are already aware of Bernoulli's rule. Okay, if you don't know the Bernoulli's rule, please go back to the last two videos we have discussed based on Fourier series. Okay, just go to that and understand Bernoulli's rule for what generalized formula for integration by parts. Okay. So first function here which is u and this is v. First function is 2x minus 1, keep it as it is. Okay. So integration of cos is sin n pi x divided by n pi. Okay. Minus differentiation of 2x minus 1 is 2. Okay, 2x is 2, minus 1 is 0. Okay. Into, it's an integration of sin n pi x by n pi. Again, it will become minus cos of n pi x divided by, already 1 n pi is already there. It will become n pi whole square. So next differentiation of 2 is 0. We are going to stop this procedure between the interval 0 to 1. Okay. So if you don't know the Bernoulli's rule, we'll recap once again. Just look at it. It's a very simple one. Integration of product of two functions. First function v1 represent integration of second function minus differentiation. U dash means differentiation of first function. V2 means double integration of second function plus double differentiation of first function, triple integration of second function, and so on. Okay, this is the Bernoulli's rule for generalized formula for integration by parts. Okay, look at student here. I am going to calculate this. Okay, okay, look at by substitution of upper limit and lower limit. Okay, so this is 2 times of, okay, substitute x equal to 1 here and observe what will happen. 2 into 1. 2 into 1 minus 1. Okay. Sin n pi x 1. Sin n pi. Sin n pi value is 0. Okay. So 0 by anything is 0. Okay. Minus plus 2 divided by n pi whole square, right, as it is. This is cos n pi, student. Cos n pi value is, you first write cos n pi itself, later you can write the value. So upper limit is over minus lower limit. So substitute 0 here. Okay, 2 into 0 is 0. So 0 minus 1 into sin 0 is 0 again. Okay. This will become plus. So 2 by n square pi square or n pi whole square, right, as it is, and cos 0. This will become cos 0. Okay. So try to observe here, which is equal to. So this is 0. Okay, you can write 2 outside. This is 0. This is 2 by n square pi square into cos n pi is minus 1 whole raised to n. Okay. So this is minus of 2 by n square pi square into cos 0 is 1. So what is common in these two? So 2 by n square pi square is common. So 2 2s are, which is 4 by n square pi square into minus 1 whole raised to n minus 1. So this is the value of an. Okay. What is the value of an? 4 by 4 by n square pi square into minus 1 whole raised to n minus 1. So therefore, what is the required cosine of range Fourier series? Okay. Therefore, 1 becomes, equation number 1 becomes f of x equal to a naught value now, which is 0, plus summation n runs from 1 to infinity. An value is 4 by n square pi square into minus 1 whole raised to n minus 1 into cos n pi x. This is the required Fourier series. Thank you so much for watching, students. We'll meet in the next video.